Okay, so we've been talking about full stoichiometry problems. Those are problems that involve a complete chemical reaction. And so let's just go an example. Let's give you another problem. Let's say that we have 2 moles of oxygen, and I want to ask you about something else in the equation. Well, the equation has to be balanced. So I have to add a 2 and a 2 here to get them balanced. And then those balancing coefficients, the numbers in front of the formula, are what we use for our middle jump when we jump from one material to another material. Because we have 2 tables, okay? So let's just make up a problem. Let's say that we have 2 moles of oxygen and we got more than enough hydrogen. We want to know, well, how many moles of this will be created? So we take our 2 materials, oxygen, we put it above one chart. We put water above the other chart. We're not using hydrogen, so it's not above, we can only do 2 compounds at a time. And our question is, how do we go from moles of oxygen to moles of water? So we look at our chart. Remember, we're going from moles to volume. And so we write down our given number, 2 moles. And we look at our chart. Our chart, we have one jump that we need. So we put one bracket next to our given number. And now we need to fill the bracket with coefficients. The rule for filling it is the one you want goes on top. I want the mole number or the coefficient number of water on top. Water has a 2 as a balancing coefficient. Oxygen in the balance equation only has a 1. And this is a molar ratio. We don't usually write them because they pretty much cancel out all the time. Okay? And so then you just do the math, because I only needed one jump. Okay? 2 times 2 is 4, divided by 1 is 4. So our answer is 4 moles. So that's how you do it. It's the same 4 steps in every flow chart, whether you have one flow chart or 2. We only added on a center jump, which uses the coefficients if you're changing between 2 different materials. So let's make this question a little bit more complicated. Rather than going to moles of water, what if I wanted to go to the amount of liters or volume of water? Well, if I'm still starting at the same place in the oxygen chart, so one chart's oxygen, the other chart is water, and I'm still not dealing anything with the hydrogen, then I want to go to volume. Then what happens is, I need to put my question mark there. I have 2 jumps to make, so my problem involves 2 brackets. So I need to add on another bracket. Going from mole to mole, it's still the same. I want the water's coefficient on top, and the oxygen, the one we came from, on the bottom. But now I want to go to volume. Volume, I need a 22.4 liters on top. And then I put 1 mole on the bottom, because the one you want goes on top. I want the volume answer. So I go through. Now my moles cancel out. I'm going to get a liter answer. So then I have 4 times 22.4. So that's going to be 88 plus 4 times 4 is 16. So 89.6 liters. Okay? So that's going to be the amount of volume of water that's going to be produced in liter form, okay, at STP. Okay, I want to switch things around with you and do some different kind of problems. We're going to stick with our same balanced equation. Remember, these work with any balanced equation. So let's just say that we have water in the gaseous form. So let's say we have 22.4 liters of water at STP, which means we can use this box up here. And let's say, well, you know what? Let's go over to oxygen. Let's go this way in the problem and figure out how many molecules of oxygen we'll need to produce that amount of water. And so it's not a hard problem. We got to do it the same way we've been doing it all along. You just identify your 2 charts. I've got oxygen over here on the left, so I'm going to put it on my left chart. I can put it on the right. It doesn't make a difference. Oxygen over here. I'm going to put water over there. Okay? And it won't make a difference. I now go back to my visual of my problem. I'm starting in the volume box for water. So here's where I'm starting. I want to end up in the particle box of the oxygen chart. Here's the oxygen chart, particle box down here. And now I've got to do a problem. And now I have a choice. I can go numerous ways. I can go across and then down, or I can zigzag down through the middle, or I can go all the way down and then across. It doesn't make a difference, but either way, it's 1, 2, 3 jumps, or it's 1, 2, 3 jumps, or it's 1, 2, 3 jumps. It doesn't make a difference. It's just going to switch around my brackets, but it'll get the exact same answer. So I'm going to choose to go across and then all the way down to the particle answer. So we're starting with our 4 steps. Step number 1, write down your given number, 22.4 liters. So I was given that much water in gaseous form. I want to figure out how many particles of oxygen, so I have to jump charts, and I got to get to this box. So it has 1, 2, 3 jumps. So there's 1, here's jump number 2, and jump number 3. So I need 3 brackets. 1, 2, 3, and that will give you my answer. So you ready? Real simple, take your time. We want to go from volume to volume. Any jump anywhere in the middle of this chart uses coefficients. The rule is the one you want goes on top. I want to end up in oxygen's chart and information. So I want to use the coefficient of oxygen first. So oxygen has no number out front, so it gets a 1 here. The one I came from, which is water, has a 2. So that is my coefficient over coefficient ratio. The one you want goes on top. Okay? Remember, it's mole and mole, but we don't write them down because they cancel out. That gave me the first jump. Jump number 2, I go from volume to mole. So I got to use this bracket right here at the top. Okay? But I want mole to be my final answer, so I'm going to flip it over. And I'm going to put 1 mole on top. And I'm going to put 22.4 liters on the bottom. Okay? That's the rule. The one you want goes on top. And then I want to make my third jump to put my bracket. I want to go to the particle number. And the particle number is already on top, and I'm coming from the mole box, so I'm going to leave it the way it is. I'll put the particle number on top. And I get to write any name I want for particles, and since they're asking me for the molecule name, I'm going to put the molecule name up there, and then put the other information on the bottom. If I've set these up correctly, then the names I don't want should cancel out. The names I do want should remain. So here we have liters. Here we have liters in the bottom. They've canceled out. Here we have mole, and mole are canceling out. So then the last name left over is molecule, and that's the answer that I would like. So now the math is all set up. So I'm going to just do the math. I have 22.4 divided by 22.4 is 1. Okay? And then 1 divided by 2 is a half. And so then I want a half of that number. And so when you take 6.02 times 10 to the 23rd and divide it in half, you get 3.01 times 10 to the 23rd molecules. Check that on your calculator to prove I'm right, but you should find out that's true. All right? So I wanted to show you in this process that you can go between reactants and products, reactants and reactants. It doesn't matter. You go from a product to a reactant, reactant to a product. These charts do not care which direction you move. As long as you set up the math correctly, you can ask yourself any question you want with materials in the same balanced equation. Thanks.